Hi, we're going to do a code walkthrough for CSC 578 Homework 1. My name is Amy Edwards. First part of the project was just to edit this NN578 network.py file in order to add some things in. This SGD definition, we wanted it to be able to return a list of interesting notations like the MSE, the cross entropy, log likelihood, the number of correct, and the accuracy. So as you can see, they're printing out here. They're printing out for the training data as well as for the test data. We also modified this in order to include early stopping. So no matter how many epochs we have decided to run, if the accuracy reaches 100%, we will break out of the loop. You can see that here. This is also just some comments out for the plots that I made for the extra credit. We moved on to edit the backprop file in order to make this activations matrix allocate memory specifically for the network that is being run, as opposed to just appending and sort of wasting more memory that way. Here we are allocating the space as all zeros, and then we are inputting to the indices of the matrix here for the input, hidden values, and then the output. This is a print statement that we'll see when we run the code snippet. This is the evaluate function that we call in SGD, and so this is doing the math for the MSE, log likelihood, cross entropy, etc. These are miscellaneous functions, and it includes the plotting functions that I wrote at the end there. So we'll move on to the code snippet for our homework. This is the printout of the activations matrix as we saw from backprop, and it matches what the homework had suggested it would be. And see here we're printing out from the evaluate and SGD functions, the epoch 0 training, the MSE value, cross entropy, log likelihood, number of correct, and the accuracy. It ends up stopping here due to early stopping, just since the accuracy is already at 1. Also prints out the same thing for testing, because we have testing data right here under this sample 2. So we're going to go ahead and get rid of the activations printing because we don't need it anymore. Save the file, restart the kernel. Then we'll move on to the XOR data set, where our idea was that we're going to run 30 epochs. I have one mini batch and ETA of 2.2, and there is no testing data. Ideally, it'll stop before 30 epochs because 100% accuracy has been reached, but depending on the starting weights, that takes a couple minutes to get the right starting weight. So unfortunately, you have to go through and run this a couple times. I took a brief pause because I had to run this about 15 times in order to have it reach a 100% accuracy before 30, but here we see at epoch 9, we have 100% accuracy right here, printing out the cross entropy for the training values because there are no testing data. So the same idea was happening now with the iris data, except the iris data is much bigger. And I was never able to reach 100%. I think the highest we got was 96. I wrote about it in my documentation, but essentially, even if I ran 100, 200 epochs, it just never reached that global maximum. Here in this particular beginning weights, it seems like the highest is 90% at 26 epochs. And then this last code snippet is what I used in order to make plots for the extra credit. At the end here, you see the cross entropy versus the epoch. Cross entropy decreases relatively steadily over time, but for the training data, it still has a much higher cross entropy than for the testing data. Well, that's about it. Thanks for your time.